A very good morning, guys. Once again, welcome for the today's lecture. As I have told you last time that we shall be starting with the numericals on the analysis of the fixed beam. By this time, we have seen near about 5 to 6 standard cases in which we have found out the fixed end moments at the fixed ends as well as the equations for the slopes and the deflection. Let us see few numericals on that particular basis. So the basic requisite to proceed with the numericals on this analysis of fixed beam, these are the various 6 to 7 cases. The very first thing which we have to understand and know by heart the values of the fixed moment for the various standard cases. In this, as far as this first 6 cases are concerned, all the cases are been understood earlier in the earlier videos. As far as this 7th is concerned, 7th case, in which we are having a sinking of the support. Here you can see B point is sinking with the magnitude of delta as compared to A, or this is also been called as when the supports are being placed at different levels. These are the various values of the fixed end moments at point A and B, which we have already solved or rather understood into the earlier lectures. So let us move ahead and start with the very first problem. In this particular problem, we have a fixed beam which has been imposed with a UDL of 450 Newton per meter and which is fixed at point A and B. In this particular situation or for this particular problem, we are in need of finding out the maximum bending moment and the deflection, and we have already seen what are the values for the maximum slopes and the deflections as well as the fixed moment for this particular sort of the standard cases. So moving ahead, we know for the fixed moment we can draw the fixed moment diagram. Here we can see MA should be equal to MB due to the symmetry of loading and the properties of the beam. So here in this particular problem, the length is given equal to 8 meter, W is 4500 Newton per meter, that is 4.5 kilonewton per meter, and EI value is also been given to us. So here we know that maximum bending moment or maximum bending moment for this particular sort of a beam has to be WL square by 12, putting the values 4.5 as this particular value and 8 square divided by 12. Therefore we get 24 kilonewton per meter as the maximum bending moment occurring in this particular sort of a beam. Second thing we have to find out in this is the maximum deflection. While going through the standard cases, we have seen the maximum deflection occurring for this particular sort of a beam. It was equal to WL raised to 4 by 384 EI. Putting all the given values into this particular equation, ultimately the maximum deflection came out to be equal to 4.8 millimeter. So this is what is the solution for this sort of a problem. Now coming to the next problem, in which again we are having a beam, fixed beam of course, which has been loaded with a UDL throughout the length, whose length is equal to 8 meter, and in this particular problem we are required to find out the load intensity on the beam, that is what is the value of W, that is the magnitude of UDL imposed on this particular thing, as well as certain conditions are been mentioned here. And those conditions are, first condition is if the maximum bending moment should not exceed 40 kilonewton per meter, and second condition is if the maximum deflection shall not exceed 1 by 400 of the span, and the value of EI is to be taken as 9.5 10 raised to 9 kilonewton millimeter square. So first case in this is if the maximum bending moment should not exceed 40 kilonewton meter. So in that case I know that the maximum bending moment for this particular case is what, 40 kilonewton, and in term of our equation we know what is the value of that is WL square by 12. So here it has been said the value of WL square by 12 should not be more than 40 kilonewton per meter. So putting these values in this particular equation, we are required to find out the value of W. I know L, it it is 8, so 8 square divided by 12 is equal to 40. So by doing the mathematical part onto this, ultimately I'll be having a magnitude of UDL that is equal to 7.5 kilonewton per meter. It is, and for one more case we have to find out the value of W. If that particular situation is that deflection should not exceed 1 by 400 of the span. I know that for this particular case the maximum deflection is WL raised to 4 by 384 EI, which should not be more than 1 by 400 of the span. So from this, by putting the values in this particular equation, we shall be able to get the value of intensity for this specific condition. So putting the values and simplifying here, I'll be having the intensity of the UDL is equal to 17.812 kilonewton per meter. So here please make the correction into this 7.5 kilonewton per meter, and this is W is equal to 17.812 kilonewton per meter. So this is what is the analysis of the fixed beam when it is being imposed with the UDL under certain condition. So we'll once again come back when we shall be solving with the next numericals, and of course those will be for the point loads acting at the various points. Thank you very much.